welcome back. Sorry that upload takes forever to create that video file. But anyways, we're looking at graphing functions again. We're going to look more at using the technology to do so. So if you could punch in negative, if you have a calculator at home, x cubed plus 4x squared minus x and minus 4 at the end, okay? Um, Now, think for a minute with me about your possible rational zeros that we talked about a couple sections ago. You see how our factors of 4 are just 4 and 1 and 2, right? And then factors of -1, of course, are -1 and 1. Well, if you were to list all your possible rational zeros, it's only plus minus 4 over 1, plus minus 2 over 1, plus minus 1 over 1, correct? But when you look at this, zoom standard, you're not sure, this is definitely not 4, nor is it 2, nor is it 1, none of those. So it looks like we have some, possibly some irrational zeros, it appears. Okay, and so your calculator really comes handy when it comes to that. So to find your zeros with a calculator, you go F5 Math, click on 0, which again is the same thing as an x-intercept. Now, our first zero is pretty close to about right there, right? But you got to give it a lower bound, so go to the left of it, which happens to be above it in this case. So I arrow to the left and I hit enter. I arrow to the right of where it crosses and I hit enter. And it gives me the zero. You see that? Negative 0.814, and this is again essentially 0. Negative 1 times 10 to the negative 13, so negative 0.000, a bunch of whole zeros, right? So negative, if I was to write 0, I'd list it. My x-intercept is at the x value negative 0.814, comma, 0. Okay, do the next one, F5, 0. Okay, it's pretty close to about right there, but I got to give it a lower bound, so I go to the left of it, which happens to be below it in this case. I go to the right of it, which happens to be above it here, and there's my 0, 1.471, comma, 0. And let's do the last 0. Okay, and these are what I would put on my, I go to the left of it, enter, which is above it in this case. I go to the right of it, which is below it here, enter. Okay, when I say lower bound to the left of it, I'm meaning to the left of the x value, right? So we went to the left, which was above it. We went to the right of it on the function, which was below it, okay? So here's our 0, 3.343, comma, 0, okay? 3.343, comma, 0. And so if you were graphing this function using a calculator, these are the points you'd put on your graph, right? You have your 3 x-intercepts there. And then you want to put on your minimum and your local maximum. So you go ahead and you find your minimum. Let's do that one first. Let me go over close to the minimum. You say, well, my minimum's about right there, right? But I got to give it a lower bound. Go to the left of it. Enter. Go to the left of the U, to right of the U now. Enter. There's your minimum that you'd put on your graph, on your paper, 0.131, comma, negative 4.065. Now let's do the maximum. F5, maximum. Okay, it's about right there. Go to the left of it. Enter. Go to the right of it. Enter. There's your maximum, 2.535, comma, 2.879. So now you got a min, you got a max, you got these intercepts. You know it's going to go up to the left, down to the right, and you can draw it pretty well using that calculator. If you needed some more points, you could trace it. You hit F3 trace, punch in, how about 0, enter. 0, comma, negative 4. How about negative 1, enter. Negative 1, comma, 2. How about 1, enter. 1, comma, negative 2. And you could give yourself a whole bunch of other points if you were too lazy to put the points in yourself, right? You could use the calculator to go ahead and trace them, to point plot, if you will. Okay. Now let's graph one more by hand. Let me escape from this here. Go back to. Okay. How about get over to the board here? Just a minute. One more graph here, and should be okay. F of x equals x minus 1, 3x plus 1, 2x minus 5. Okay. Well, we're going to start out finding our x-intercepts again. So we're going to let f of x be 0. And our y value is 0 for the x-intercept. And I say, oh, 1, negative 1/3, 5 halves. I already got something put on my graph. So 1, comma 0, negative 1/3, comma 0, and 5 halves is just 2.5. Okay, you see the 3 zeros here? Okay, so you go ahead and you get your x-intercepts on there. Number 2, let's talk about end behavior. Now this is not in your old standard polynomial form, so we're going to have to make it before we analyze this. I'm going to go ahead and do these ones first. Combine those. 6x squared minus 13x minus 5. Go ahead and distribute that x through, distribute the negative 1 through. I got 6x cubed minus 13x squared. You know, the rest of it I really don't care about because all I care about is my end behavior here. Okay, so I have the degree 3, so the n is odd, all right? And my leading coefficient, which is that 6, my leading coefficient, oops, I'm supposed to say greater than. My leading coefficient is positive, okay? So I know it behaves kind of like the old regular x cubed. So it's going to go down to the left, up to the right, okay? And then I just start plotting some points on here. Okay, so number 3, plot points, okay? Now we already have, let's see, we know that 1, 0, we got the 2.5, 0, 2.5 is 0. We got negative 1/3, negative 0.3 repeated, comma 0, right? There's your negative 1/3, comma 0. So we could put in, you know, some other points here. And let's see what you'd get here. Let's plug in, how about, let's plug in 0. So if you plugged in 0, I'm trying to see where it has some room here. I'll put it over here. 0 minus 1. 3 times 0 plus 1. 2 times 0 minus 5. So we got negative 1 times 1 times a negative 5. So it ends up being 5. So 0, comma 5, right? Plug in, we already got 1, right? We already got the 1 right there. So it's probably going to go, you know, it's going to go up here pretty sharp, and it's going to come back down here, and then somewhere, you know, between here. And of course, you could use your calculator for all these, but we better plug in at least 2. Let's plug in 2 here. So f of 2, 2 minus 1, 3 times 2 is 6, plus 1, and then 2 times 2 is 4, minus 5. Negative 7. So at 2, we got negative 7. 2, and I gotta erase this to put my point on there. Comma negative 7, right? And of course, you could put some more points on there. Who knows if that's perfectly the minimum, but at least for algebra 2, we're kind of stuck at this point. If we had calculus, we could find those mins and maxes very nicely using the derivative, but yeah, that's kind of what it looks like here. And of course, the more points you put in, the better this thing looks. And I would be using my calculator to help me to point plot in this case anyways. That would be appropriate. Okay, so that's it for this section on analyzing graphs of polynomial functions. Thank you.